today actually deals directly with these ones and zeros. But ones and zeros do play a big role in how computers work on the inside.
Inside a computer are electric wires and circuits that carry all the information in a computer. How do you store or represent information using electricity?
Well, if you have a single wire with electricity flowing through it, the signal can either be on or off. That's not a lot of choices, but it's a really important start. With one wire, we can represent a yes or a no, true or false, a 1 or a 0, or anything else with only two options. This on-off state of a single wire is called a bit, and it's the smallest piece of information a computer can store. If you use more wires, you get more bits. More ones and zeros, with more bits, you can represent more complex information. But to understand that, we need to learn about something called the binary number system.
In the decimal number system, we have 10 digits from 0 to 9, and that's how we've all learned to count. In the binary number system, we only have 2 digits, 0 and 1. With these 2 digits, we can count up to any number. Here's how this works. In the decimal number system we're all used to, each position in a number has a different value. There's the 1 position, the 10 position, the 100 position, and so on. For example, a 9 in the 100 position is a 900. In binary, each position also carries a value, but instead of multiplying by 10 each time, we multiply by 2. So there's the 1's position, the 2's position, the 4's position, the 8's position, and so on. For example, the number 9 in binary is 1001. To calculate the value, we add 1 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. Almost nobody does this math because computers do it for us. What's important is that any number can be represented with only ones and zeros, or by a bunch of wires that are on or off. The more wires you use, the larger the numbers you can store.
With 8 wires, you can store numbers between 0 and 255. That's 8 ones. With just 32 wires, you can store all the way from 0 to over 4 billion. Using the binary number system, you can represent any number you like. But what about other types of information, like text, images, or sound? It turns out that all these things can also be represented with numbers. Think of all the letters in the alphabet. You could assign a number to each letter. A could be 1, B could be 2, and so on. You can then represent any word or paragraph as a sequence of numbers. And as we saw, these numbers can be stored as on or off electrical signals. Every word you see on every web page on your phone is represented using a system like this. Now, let's consider photos, videos, and all the graphics you see on a screen. All of these images are made out of teeny dots called pixels, and each pixel has a color. Each of the colors can be represented with numbers. When you consider that a typical image has millions of these pixels, and a typical video shows 30 images per second, and we're talking about a lot of data here.
Every sound is basically a series of vibrations in the air. Vibrations can be represented graphically as a waveform. Any point on this waveform can be represented by a number. And this way, any sound can be broken down into a series of numbers. If you want higher quality sound, you would pick 32-bit audio over 8-bit audio. More bits means a higher range of numbers.
When you use a computer to write code or make your own app, you're not dealing directly with these ones and zeros, but you will be dealing with images or sound or video. So if you want to understand how computers work on the inside, it all comes down to these simple ones and zeros and the electrical signals in the circuits behind them. They are the backbone of how all computers input, store, process, and output information.
All right, cool. So again, the last video we talked about the 4 functions of a computer. The 4 functions of a computer, we talked about input, storage, processing, and output. That's input, storage, processing, and output. So the last video we talked about the those 4 things that all computers do. That video was about binary code and basically how those 1s and 0s represent every single thing that you see on the screen. So a series of 1s and 0s, that binary code is how the computer reads the text, reads the videos. It tells the computer what colors. It tells the computers what letters. It tells the computers what sound. It tells the computer, those 1s and those 0s are how the computer reads everything. And that's called binary data. And we use the suffix bi in binary because bi means 2. So that's why the word is binary. When you hear somebody say something is binary, that means there are 2 choices. So if when you look at your shoes, when you decide what shoe you're going to put on first, you're making a binary choice. You only got 2 choices, left or right. So that's a binary choice. Just like with programming computers, the binary choice that you have is a 0 and a 1. And we use those 0s and those 1s in a series of different ways and in different patterns to create different things on the screen. All right. So, and again, we're not expecting you guys to learn all of this stuff today. Our goal is to get you exposed to it so that you hear it. So you start to get familiar with those terms. And so you start to get familiar with how those computers work that you use every single day. All right. All right, cool. So now let's get into our lesson. Let's get logged in. I'll get logged in and we'll see where we are. Okay, here. This is North Side and this is Wednesday at 2:15.
Mute your sound on your computer right quick.
You? Turn on.
All right, so is this the class with Melissa Ortega?
No.
Okay, though. So this is Northside, right? Okay, Northside Elementary, Wednesday 2:15. All right, so we are with this class, right? So is Twain Ball in this class?
Yes.
Okay, so this is this class. Okay, cool. All right, so I see we're just getting started. So let me pull up our course.
Make sure y'all listen good.
So the first thing I want you guys to do is everyone, okay, on this lesson 1, let's click this unplugged activity, but you're not going to watch it on your screen. You're going to click this orange button. So click this orange button that says finish, continue to next stage.
Okay, you click on the finish,
So it's and that should take you here. Okay. Once you get here, oh, I'm sorry. Let me share my screen again. I'm sorry. I'm not sharing my screen. Sorry about that.
Click this unplug. The button that says unplug. The first one at the top. Yeah. Click that. Then click the orange button.
Yeah, so here again, it starts here. You click unplug, and then you click this orange button here. And then that should take you here. I also want you to press continue. We're going to watch this video on the screen. And you guys may have watched this video already, but I want you to watch it again so you get a better understanding for what we're doing. So you guys press continue. You're not going to watch it on your screen. I'm going to press it so we can watch it on my screen.
Today, we're going to learn to program using a drag and drop language called Blockly. Blockly uses colorful instructions called blocks to build programs that you can use to solve puzzles. Under the hood, you're still creating code. Each puzzle you'll solve with the code is split into 4 main parts. On the left is the play area, where your program will run. In the center, you will see the toolbox area that holds all the blocks that you will need for each puzzle. To the right is your workspace, where you will drag blocks to build your program. Finally, above the workspace, you will see the specific instructions for each puzzle. Don't worry if you accidentally drag out a block that you don't need. If you have an extra block, simply drag it back into the toolbox to put it away. After you hit run, you can always hit the reset button to get your character back to the start so you can try again.
All right, continue. So we should all be here now. 1 second, I'm gonna pull up our class and see where we are. Okay, so most of us are here on lesson 2. I see Hayden is done with lesson 2. Corey is done with lesson 2. Okay, so if you're done with lesson 2, then you can move on to lesson 3. For most of us in the class, it looks like we're working on lesson 2. So I'm going to work with you guys through lesson 2. So if you have any questions, I'm going to work with you. I'm going to start with puzzle 1, and I'm going to make sure everyone has it before we move on. So here, let me start over. All right, so here I see that, okay, so we have, where's Zarnice? Zarnice Brown?
Yeah, she's in the opposite classroom.
Okay, cool. I picked the wrong one. Okay, let me, okay, cool. Okay, so we're here now. Start over. So the ones that have the green checks have already done this one. Everybody that's white hasn't done it. Everybody that's yellow has just started on it. So let's start here. All right, so you see your names here in this corner. So once you guys finish the puzzle, I should see when everybody's finished. So here, let's read the instructions. For this puzzle, snap all of the blocks together, click run, and watch it go. So again, we're trying to get the Angry Bird to this green pig. We're trying to get the Angry Bird to the green pig. He has to move 2 spaces to get to this pig. Each of these square areas here, like you can see this TNT box, or you can see this triangle. Each one of these square spaces is 1 move. So he needs to move 2 spaces forward to get there. We already have our 2 move forward commands here. All we're doing here is practicing dragging and dropping and connecting the blocks. So put your mouse over the first move forward block, grab it. You see, once you grab it, you can move it around. You can place it anywhere. We're going to attach it to the when run block. So when we run this program, the bird moves forward. So when run move forward, take the second block, attach it, move forward, and then click run.
Alright, listen. You trying to get that Angry Bird to that point. Angry Bird, I want you. You gotta move forward how many times? You gotta move forward one time, you gotta move forward again, right?
So you're just gonna click. So again, we're just attaching these blocks to the bottom of the win run block. So when we run this, what that win run block means is when we run this program, is gonna do these two commands: move forward, move forward, move forward, move forward. So that's what it should look like. Then you click run. So once you do it, click continue. Okay, so now I'm seeing, let's see, Michael, May, Jaden, Riley.
Yeah, he's not in this class.
Okay.
You trying to fix it? How many blocks you see in front of you? 1, 2.
Hey, so you guys got it? Who all didn't get that puzzle? Raise your hand if you don't have it.
Yes, we go back and let the trash can. You're trying to get from here to here. Next.
Cool. Hey, let's pay attention to our class. So who doesn't have it?
I got it. 1, 2. Yeah, run.
I don't got it. I have it. I got it.
Again, all you're doing is clicking these 2 blocks. So the two blocks on the screen. So you should be on puzzle 2. You should be on puzzle 2.
Yeah, go back. Raise your hand if you need help. Okay, I'm coming. Alright, why you think?
And also too, class. Up here, if you look here, look at the screen. If you look here, where this purple bar is, you should see something that says start over. So if you ever get to a point where you're too lost on a puzzle, click here and click start over, and then that'll reset that puzzle. So right here on this purple bar, it says start over. So if you too messed up, you can click start over. So all you were doing is attaching 1, 2, and then click run.
Wow. You got so many sweets.
All right, so let's go to the next puzzle. Puzzle 3.
Excuse me, can you please wait?
So let's go to puzzle 3. Who doesn't have puzzle 2? Okay, so let's go to puzzle 3. You don't have puzzle 2? So let's go to puzzle 3. You should see right here at the top the different puzzles. It should have took you straight to puzzle 3. So you see at the top here, this is what it tells. So we should be on puzzle 3. So let's read the instructions. Drag an extra move forward block out of the toolbox, then attach all blocks to the win run block to finish your code. So the bird this time has to move 1, 2, 3 moves to get to the pig. we already have 2 move forward blocks. So let's click 1, 2, and then grab one out of the toolbox here. So you should have, here you should have 3 move forward blocks. Okay, and then click run. Hey, and it's not that hard if you're paying attention. Pay attention to what you're doing on your screen. Okay? So it's not that hard if you're paying attention. All right, so let's pay attention and make sure we get it done. All right, so let's go to puzzle 4. Okay, hey, class, pay attention. All right, pay attention.
Everybody stop.
All right, everybody pay attention. So take a look here. All right, so let's read the instructions. This pig is ruffling my feathers. There is 1 extra block that is going to cause the bird to crash. Throw it away by removing it from the other blocks and dragging it back to the toolbox. Now, hey, make sure you're paying attention and listen. When you look at the instructions up here, you also have a play button right here. So if you're having trouble reading the instructions and knowing what needs to be done, you can go here and press this play button. All right, and when you press the play button, it'll read the instructions. So I'm going to have the play button read the instructions again, because you have to know what you need to do before you can do it.
This pig is ruffling my feathers. There is 1 extra block that is going to cause the bird to crash. Throw it away by removing it from the other blocks and dragging it back to the toolbox.
All right, so again, we have 1 extra block here that is going to cause this program to fail. So I'm going to run it as is now. I'm going to run the program as it is now, and let's see what happens. So I click run. Okay, and you see he ran into the wall. He ran into the wall because our program is wrong. Okay, so he needs to move forward only 1 time, and he moved forward twice. So in order to fix this problem, we have to get rid of this blue move forward block. In order to do that, you have to expose it. So what you do is you grab all of the blocks underneath that block. Okay, whatever block you grab underneath that block, you'll take them with you. So if I grab this block, it moves that block and everything underneath it. So now I can grab this one. All right, because now it's exposed. All right, so if I would have just tried to grab that, it would have grabbed everything. Okay, if I would have just tried to grab it. See, it grabs everything underneath it, comes with it. So I take this and I sit it to the side. All right, I'm going to sit it to the side right there. And you can always sit code to the side. All right, and it's not going to do anything if it's not attached to the win run block. Then you take this green block, take it, put it back into the toolbox. Get rid of it. All right, because we don't need it. Because he only needs to move forward 1 time. They had it programmed where he would move forward twice. All right, now we take the rest of our code, and again, it's move forward, turn left, move forward, move forward. He needs to move forward, then he needs to turn left, then he needs to move forward twice to get to the pig. All right, so let's click run. Did everybody get that done?
Yeah.
Okay. Hey, and if you're farther along than the rest of the class, that's fine. You keep working. Okay, you keep working and you keep going as long as you're completing puzzles. Do not skip any puzzles. Okay? Hey, pay attention. Do not skip any puzzles. All right? If you get to a puzzle that's hard, keep working on it until you fix it, or raise your hand and I'll help you out. All right? But do not skip any puzzles at any point in the lesson. Finish every puzzle before you move to the next one. That's very important. Okay, now we on puzzle 5. All right, all right, so let's have our instructions read.
Trace the path and lead me to the silly pig. Avoid TNT or feathers will fly.
All right, trace the path and lead me to the silly pig. Avoid TNT or feathers will fly. So we just need to trace a path to get to this pig. So he needs to move forward. Then he needs to turn right. So, and we can check it as we go. So if I click run, okay. So now I see, okay. So I checked the first part. He moved forward and he turned. So I know that's right. Now from here, he needs to move forward and turn again. So he needs to move forward and turn left. Let's check this and make sure. Let's check and make sure we're right along the way. All right, so that's right. And now we need one more move forward. So that's what that one looks like.
Oh no, I did. Turn left.
Come on.
All right, so that's what that one looks like. So how are we? Are we doing okay?
I got him. Yes, I got him. Good job, bud. Good job.
So Claiborne and Kaylee. Kylie. Claiborne and Kylie. You guys are still working on that one. I see yours is still yellow. So are you having trouble?
I'm getting you right. You're gonna move forward.
So here is the solution right here. You see it on the screen right here. Right? Again, I'll go through it again with you guys.
So Claiborne and Callie, look up at the screen. He's gonna go through what you should put.
All right, so we have to trace our path to get him to this pig. So he needs to move forward. So okay, move forward. And then he needs to turn right. So again, I'm going to click run and I'm going to check it as I go to make sure. Okay, so he's there now. So we've written enough code to get him to this point. So now from here we need to get him to move forward and turn left. Okay, so let's move forward and turn left. And then let's run. Okay, so now we have him there. So I'm going to press reset. Okay, so the last thing he needs to do is move forward one more time.
Yeah, let's go ahead, start over.
So Kylie still hasn't gotten it.
All right.
Kylie and Keisha. Callie and Keisha. So here's the solution here. Move forward, turn right, move forward, turn left, move forward.
You understand how to do it?
So, they got it?
We have to be backing it up now because they get on the bus and
okay, cool. All right. right. Hello. All right, guys. Hey, we can wrap it up. Great job today. You did good getting logged in. We're moving along. Let me show you guys kind of what I'm looking at, so you can see where you are in the program and what you're doing. And again, we're tracking you guys the whole way. We're tracking you guys through the program the entire way. So hold on, let me click here. I think this is our class. Yes. Okay. So, and we can see levels completed. Levels completed so far. We have the Nisha. We have Hayden. We have Corey, Tawan, and Timothy. Our top 5 students. We have Denasia with 11 levels completed. Okay, Hayden, you're completing a lot of levels, but you're using a lot of code. So we need you to try to complete the levels, but try to complete them. Oh, you can't see, right? Sorry about that. I want you guys to see, and then I'll let you guys go. All right. So here we have Denasia, Hayden, Corey, Tawan, and Timothy, the top 5 in the class. You see, the most we have completed is 11 levels. Hayden, you're doing a good job completing the levels, but you guys are using a lot more lines of code. You see, Denasia did 11 levels with only 55 lines of code. You guys are 11 and 10 with 122 and 112. That's double the amount that she's using. So again, we want to make sure you're not only doing the puzzles, but you want to make sure you're being efficient with how you do it. Right? You want to use the least amount of lines of code as possible to solve the puzzles. Okay. So again, that's the end of our class for today. I'm proud of you guys. You did a great job. You can also work on this when you're at home. All you got to do is go to code.org and you can practice while you're at home, so you get better while you're at home. All right. So again, yeah, they can practice while they're at home. If they know their secret picture and they have their class that log in with their class code on the end of it, they can log in while they're at home. But even if they're not logged in, they can go to code.org and they can practice. So they don't have to be logged into their system to actually practice doing it. All right. So again, I'll see you guys next week. Great job today. I love you. I'm proud of you. And I'll see you next week. All right. Bye-bye.